Hello, my name is Tori, and I am going to talk about the biochemistry case studies, two in fact that I want to talk about. The first one is going to be case 3, and it talks about a 5-year-old boy who's brought to the pediatrician's office for an annual visit. The mother reports that the baby is pretty sickly, often appears drowsy, and she's concerned because he has excessive thirst and frequent urination. When blood samples are taken, they look at the insulin levels. They tend to be pretty low compared to the normal insulin levels, which we'll talk about in just a couple minutes. And basically, the case study is asking, what is the information likely to suggest about the underlying biochemical basis for the patient's symptoms? So I believe that the patient has diabetes mellitus or type 1 diabetes. This occurs when the beta islet cells of the pancreas are damaged. And these are important because they secrete insulin in response to large, high levels of blood glucose concentration. And what insulin plays an important role in doing is bringing glucose from the blood into the cells to decrease the blood glucose concentration. So when these cells are damaged, it decreases or completely eliminates the secretion of insulin, thus stopping the body's ability to produce an important hormone in decreasing blood glucose concentration. So the table showed that the boy had low levels of insulin, which correlates with my idea that there's some kind of damage to those beta islet cells and lower levels of insulin are being secreted. In like type 2 diabetes, it's more of insulin resistance that you tend to see. So that one would have a large, a normal, maybe even large level of insulin, but you'd still have the inability of the receptors to be noticing it, thus bringing the glucose still wouldn't be bringing into the cell. This one, we have low levels of insulin. Thus, there's some damage to where the insulin is being secreted from, which is the beta islet cells in the liver and the pancreas. Symptoms of the disease are known as excessive thirst, fatigue, and frequent urination. And understanding why you have that frequent urination, excessive thirst, you must understand, obviously, the role of insulin and glucose. As I said, insulin, brings the blood glucose levels down by encouraging glucose to be shuttled into the cells of the organs and lowering that level and bringing all of that glucose in to be stored as glycogen. So when blood glucose is not able to be doing that due to an inability of insulin to be secreted, we've got all of this blood glucose. The body has to find a way to get rid of it. So what it does is it is drawn down and filtered through the kidneys and urinated. So excessive urination, trying to get as much of that blood sugar down so we can really balance out the blood sugar levels, the blood glucose levels, and the cell glucose levels. So we're trying to balance that out. So that's why they're filtered through the kidneys and you urinate it out. But if you also know, a pretty common thing is that water follows solute. So that glucose, all those glucose molecules are really drawing water out from the body. And so that's why you're getting all this frequent urination. Dehydrates the body consistently because you're frequently urinating. So you've got this excessive thirst because the body is dehydrated now. You want to rehydrate the body, but you keep dehydrating it by urinating frequently, trying to rid the body of the blood glucose, the high levels of the blood glucose. So that explains why you've got that excessive thirst plus the frequent urination and how they kind of correspond with each other. The next question of the case study is, what would you predict the patient's fasted blood glucose levels to be given his current condition? Above the normal range, within the normal range, or below the normal range? So like I said, when they gave us the little table of the insulin levels were lower. So what I predict is that the blood glucose levels would be extremely high because there's not enough insulin to bring that blood glucose into the cells. Due to my prediction that we are looking at a diabetes mellitus situation, there's not enough insulin to bring all of the blood glucose into the cells. Thus, there's going to be a higher level of blood glucose concentration. The low level of insulin obviously is the perfect indicator of this. And the last question would be, the last request was, list 2 regulatory enzymes that are likely to be active in this individual's current condition. So glucose 6-phosphatase, PEP carboxykinase, and pyruvate carboxylase all increase in the liver with diabetes. But if insulin levels are lacking, as is in diabetes mellitus, the level of cyclic AMP increases, and thus the protein kinase A is activated. most of us will know protein kinase A as PKA. And both of these play a pretty important role in controlling the phosphofructokinase 2 and fructose 2,6-bisphosphatase. The enzyme is phosphorylated, activating the bisphosphate and lowering the fructose 2,6-bisphosphate level. The glycolysis is then inhibited and gluconeogenesis is activated due to this lowering. So glycolysis, you're breaking down that glycogen. Gluconeogenesis, you're making more of that glucose due to the lowering of that glycolysis. Increased cyclic AMP levels simultaneously inhibit the synthesis of glycogen and encourage breakdown. It is super dangerous because the glucose levels keep increasing because gluconeogenesis and the glycogen breakdown are both being activated in the liver. So it's terrible because you have these high levels and the body's trying to get rid of it, but also at the same time with the low levels of insulin, more cyclic AMP is increasing while the PKA is activated. So the blood glucose level keeps going up and up and up and up and up and up and up. And that's why it's so dangerous. There's type 1 diabetes mellitus. That's why you hear those people with insulin injections, because if not, the blood glucose levels are going to go over the top and actually become super dangerous health-wise for them. And the other case study that I worked on was the case study 4. This spoke about a previously healthy 2-month-old female presents with jittery spells several hours after breastfeeding. Mother reports she has not given the baby anything to eat other than the breast milk since birth. So the baby has recently started sleeping for more than 2 hours between feedings, and that's when the symptoms started, the mother claims. So the laboratory results resulted in hypoglycemia, which is low blood glucose, so opposite of what we were looking at before. And then epinephrine is administered, and there is an increase in blood glucose, but there's an increase in there's no increase in blood glucose, but there is an increase in blood lactate, which is highly important. We'll talk about in just a bit. Physical exam reveals that the liver is enlarged and blood glucose levels increase after breastfeeding, but she's not able to maintain those blood glucose levels within a normal range during the fasting period. So based on the information above, they want to know which of the following is the most likely diagnosis of the patient. They give us 4 different things to look at. I'm going to go through each of them and let you know which one I believe it is. So the first one is hereditary fructose intolerance. This affects a person's ability to digest the sugar fructose. Fructose, we obtain it through the diet. This occurs because there's an absence of catalase B. Catalase B is important because it cleaves fructose 1-phosphate. So without it, it's not cleaving that fructose 1-phosphate, and you have an accumulation of the fructose 1-phosphate in the liver cells, which is extremely toxic. Basically, any accumulation of anything isn't really good for the body. The body likes to keep a pretty natural balance of everything. So when that fructose 1-phosphate accumulates in the cells, it's pretty toxic. Then when fructose 1-phosphate is broken down, which is not obvious here, but when it is broken down, some of the products that play a role in creating energy and helping to maintain the blood sugar levels. So that kind of shows that fasting, where they're not able to maintain those fasting levels, but you know what I mean. Some symptoms of this are nausea, vomiting, and chronic fatigue. The next one is galactosemia. This occurs, it's an inherited mutation that eliminates the activity of galactose 1-phosphate urdosyltransferase. This stops the cells from processing galactose. Due to this inability to process galactose, there is a buildup of galactose 1-phosphate to a toxic level. Again, accumulation, pretty toxic for the body. Symptoms of this are loss of appetite, vomiting, lethargy, and abnormal bleeding. The next one is glycogen storage disease. This is caused by an accumulation of glycogen in the cells. So glycogen is a stored version of glucose. So that's once it's already in the cells, it's stored as glycogen. When it accumulates in the cells, it can impair the ability of most organs. And this disease is usually observed around 3 to 4 months, and at the same time where baby begins to sleep throughout the night and is eating less frequently than a newborn. Newborns eat pretty frequently, and as they get older, there's less frequency in the feeding, thus longer fasting states. When there is a mutation in the glucose 6-phosphatase gene, it prevents the breakdown of glucose 6-phosphate. This causes a buildup and accumulation of the glucose 6-phosphate, which then forces the body to convert it into glycogen. Basically, in large amounts, it's excessively dangerous, results in symptoms such as an enlarged liver, low blood sugar, high lactate levels. This is the correct answer. I'm still going to go over the last one, but this is the correct answer. When there's no glucose 6-phosphatase activity, the glucose is unable to be released from the liver. The high level of glucose 6-phosphate results in increased rate of pentose phosphate pathways. And this is an increased rate of glycogen breakdown to make pyruvate, which then spurs on the lactate production, which can lead to lactic acidosis, which we're seeing here, obviously. The last one I want to talk about is glucose 6-phosphate dehydrogenase deficiency. This occurs when there are low levels of glucose 6-phosphate dehydrogenase. And this enzyme is pretty important because it plays a vital role in protecting red blood cells from damage and premature destruction. It's the first enzyme in the pentose phosphate pathway. This results in the creation of NADPH. And NADPH, as we know, helps to protect cells from reactive oxygen species, which are super dangerous. Without it, the red blood cells break down in what is known as hemolysis. So pretty important, maintaining those red blood cells, maintaining the whole life. If not, you have really short-lived red blood cells. The body has to work even harder. Less ability to carry oxygen as well. So the symptoms of this deficiency are anemia, jaundice, and pain in the abdomen. So overall, like I said, I described all 4 of these, but the one that I believe is the correct answer is the glycogen storage disease, because it perfectly describes that high lactate, the lower blood glucose levels, the enlarged liver, and the 2-month-old who just started sleeping more. And with the glycogen storage disease, it's around 3 to 4 months, and when they start to sleep more and less frequency of eating. Thank you.